Okay, question 4. The diagram shows the velocity time graph of a car. We all know what a car looks like. Moving along a straight road, where v is the velocity of the car at time t after it passes through the point A. It passes through with velocity 18, moves with constant acceleration until t equals 5, subsequently moves with a constant velocity until it is 300 metres from A. When the car is more than 300 metres from A, it has a constant deceleration of 6 metres per second until it comes to rest. Find the greatest speed of the car. Okay, well this is quite an easy start bit, isn't it? Because if we think of what we've been told here, we've got, well we can do it from the graph, but actually we've got an initial velocity of 18. We've got an acceleration we were told about of 2.4 that is going on for a total of 5 seconds and reaching a final velocity v. So it's all really nicely set up to use v equals u plus at to give us our maximum velocity, which is 18 plus 2.4 times 5, I should have done that in my head, is 30 metres per second. Okay. Calculate the value of t for the instant when the car begins to decelerate. Well, my first instinct of this is to go now to the graph and do this geometrically. Because if we think about what we're told here, it starts to decelerate until it goes at constant velocity until it's 300 metres from A. So what we've got is in our little diagram, which was doing something like that, this area is 300 metres, isn't it? We start at 18 there, we go up to 30 there, we've got, what have we got? Yeah, so we've got that this is 5 and this is t. And this is what we're trying to work out. So we can try and do some stuff with this shape because the total area is 300. So I think what we're looking at is the area of this trapezium plus the area of this rectangle adds up to 300. Does that seem like a reasonable way of doing it? Mm-hmm. So the area of this trapezium is half the sum of the parallel sides. That's how you work out the area of trapezium. A half of 18 plus 30 multiplied by the distance between them times 5. So that's the distance it will have covered in the first 5 seconds, plus the next bit of distance, which is a rectangle. So that is 30 times this distance here, which is t minus 5. And though this gives us a nice equation that connects these values. That's 120 plus 30t minus 150. So 300 is 150. So that's 330 is 30t, so we get t is 11 seconds out of that. Good stuff. Right. Quite a few different ways that we could have done that. The mark scheme has a number of different approaches, although actually the way that we've done it is I think the first one that they do. But there's quite a few different ways you could have looked at that. You could have broken it down into sections and then done some SUVAT constant acceleration equations kind of thing with it. There we go. That was 5 marks for what we've just done, which feels pretty good, doesn't it? calculate the distance from A of the car when it is at rest. Okay? Well, actually, if we think about what's going on here, we know that at this point it's gone 300 metres. So actually all we're really interested in is what distance does it cover in the time that it's decelerating. So I think we can afford to go back to equations of constant accelerated motion now and say in the final little bit of motion, what do we know in the final little bit of motion? It decelerates with a rate of 6 meters per second until it comes to rest. So it has an initial velocity of 30, it has an acceleration of minus 6, it has a final velocity of 0, and the bit that I'm now interested in is how far does it take, what's the distance it covers in the time that it's doing that final little bit of motion. So this looks to me like we're doing v squared is u squared plus 2as again, 0 is minus 6 squared, that's, no, 30 squared, sorry, I've read them on there, plus 2 times minus 6 times s, which is going to give us, what are we looking for with this? It's going to give us 30 squared divided by 12, so s is 75 metres. So that's a further 75 metres, isn't it? After the initial 300 metres that it travelled. So the total distance is the 300 metres while it was accelerating and then travelling at constant velocity, plus the 75 metres while it was decelerating, giving us 375 metres. Mega. 10 marks for blasting through that. And that's mechanics.